Alright, now for 3 and 4, these are a little bit different. When we start off with sine to an even power or cosine to an even power, we can't use the same approach as 1 and 2. Here, we're going to have to use a different trig identity. We have to use the half angle formulas. These two right here. So one of these two is what we're going to need. And sometimes we may need to do this more than once, and that's going to happen here in number 3. So for number 3, what we need to do here is rewrite sine to the 4th as sine squared squared. But in place of sine squared, we're going to use this identity. Leave some room because this one's going to take a little bit more space than number 4 is. This one, we're going to have 1 minus cosine of 2x over 2, that whole quantity squared, times dx. So we have to multiply that out on the inside. So on top, 1 minus cosine of 2x times 1 minus cosine of 2x, we would get 1 minus 2 times cosine of 2x plus cosine squared of 2x all over 2 squared, which is 4. Now, this 4 in the bottom, we can kind of pull that out in front of the integral. We can take that 1/4 out in front of the whole thing. Then what we're going to need to do is look at these three parts here, 1 minus 2 cosine of 2x plus cosine squared of 2x. And we're going to have to split those three into 3 separate integrals. Take them in smaller parts. So this 1/4 still out in front of everything. We're going to have the antiderivative of 1 dx minus the antiderivative of 2 cosine of 2x dx plus the antiderivative of cosine squared of 2x dx. For this, the first part is a pretty simple antiderivative. For that, and keep this 1/4 out in front of everything, but the antiderivative of 1 dx is just x. The second one, a little bit more complicated. Here we're going to need to use u substitution. So u is going to be 2x, which means du is just 2 dx. We've got both of those in there. So really this would be like minus antiderivative of cosine of u du, which is something we can figure out pretty easily. Now this last one, I'm going to leave it how it is for right now because that's going to take a little bit more work. We're actually going to have to do the same process here all again for this because it's cosine squared. But let's go ahead and simplify this first part. 1/4 is still out in front of everything. X minus antiderivative of cosine is sine. So we've got minus sine of u, but we know u is just 2x. Now, for this last part here, we have cosine squared of 2x. We're doing the antiderivative of that. Think of this 2x as just one thing. We can almost think of it like a u type of thing, but cosine squared, if that's an even degree, like we set up here, we have to use one of these identities. So in this case, we're using the other one. We're going to have 1/4 times x minus sine of 2x plus, in place of this, we need to do 1 plus cosine of 2x over 2. But really, that it's not 2 times x, it's going to have to be 2 times 2x. So we're putting 2x in the place of this x right here. So we would have 1 plus cosine of 4x all over 2. So then we've got our 1/4 out in front of the whole big thing. X minus sine of 2x plus this one, we can take that 1/2 out in front of that integral, kind of like we did the 1/4 originally. And we've got 1 plus cosine of 4x dx on the inside. Now we can do the antiderivative of this, but we need to use u substitution again. So down here, u is going to be 4x, du is going to be 4 dx. So we have to multiply the inside by 4, outside by 1/4. So the first part still remains the same. Here we're going to have 1/8 times the antiderivative of 1 plus cosine of u du. We're almost there. A couple more steps. 1/4, and we've got x minus sine of 2x still, plus 1/8 times antiderivative of this. Antiderivative of 1 in terms of u is just going to be u, plus antiderivative of cosine of u is going to be sine of u. And at the very end, we can't forget our plus c. Now, last thing we need to do is go ahead and substitute that 4x back in for u. So our final answer here, 1/4 times x minus sine of 2x plus 1/8 times 4x plus sine of 4x plus c. So we could distribute those fractions, but this is just fine how it is. Now, this one's much tougher than number 4 is going to be. We don't have to do number 4 twice. It's just a one-step process. We don't have to go through as much. So go ahead and try number 4 on your own.